In lesson 3-2, you're just going to be using a lot of the skills you've already learned in chapter 2, and then also skills from yesterday's lesson, from lesson 3-1. So it should be nice because you can just kind of work on some of the things you've already seen before and tie them together. Example 1 asks you to solve x minus 3 is less than 5, and then it asks you to graph the solution. So when you go to solve these, you're just going to use your inequality like it's an equal sign, like you solved equations. So you draw your line out of that inequality, and then you just isolate x. So I'm sure all of you noticed by now, you just add 3 to the other side, and now you have x is less than 8. As soon as you have x isolated, then you've solved it. So now you know all numbers less than 8 are solutions to that. When you go to graph it, you're just going to do exactly what we did yesterday. Draw your number line. Notice how I'm using my line to make a number line. You should be doing the same thing. I'm going to go ahead and start at 8 here. And you have to do the same thing you did yesterday. Are you going to have an open or a closed dot? And because it's not or equal to, it's open. It's not part of the solution. And then you take one of the numbers on either side that you think is going to work. Try it and make sure. Something like 4. Is 4 less than 8? Yes, it is. So because 4 is less than 8, I'm going to highlight the side of that dot that has 4 along with the arrow. Let's write a little bit on the left. Treat the inequality treat the inequality like an equal sign and isolate the variable. So that's all you're doing on these. And then you're following the same rules from graphing as yesterday. So let's try another one. Example 2. Solve 12 is less than or equal to x minus 5. So again, just because the variable moved, you don't have to worry about that. Do exactly what you did. Just draw your line out of your inequality like you would an equal sign. And then you're trying to isolate, and if you're getting confused, you can always go to your highlighter. You're isolating that variable. Opposite, an inverse operation would be add 5. Now I have 17 is less than or equal to x. X is isolated. And it asks me to graph also, so we're going to graph that. So I'm going to go ahead and start at 17 here, 19, 21, 15, 13. And you have to do the same thing we talked about yesterday. First you have to check, is it an open or a closed dot? Because it's or equal to, it's part of the answer, so you shade it. And now you look at a number that you think works. Now a lot of you, again, I talked about it yesterday, are used to looking and seeing which way that arrow points. But check this one. Is 17 less than or equal to 15? Or is it less than or equal to 13? No, it's not. The variable moved around, so we need to think of it the opposite way. Let's try a number like 19 or 21. Is 17 less than or equal to 19 or to 21? Yes, it is. So this is all possible solutions to that inequality. And it goes on forever. All right, let's try one more. This one, I'm going to write it out. I want you to pause it and try it on your own, and then unpause and check it. Solve y plus 5 is less than -7, and then graph it. So hit pause, try it, and then unpause. All right, so you should have drawn your line out of your inequality, and then you were trying to isolate the y, so you subtract 5 from both sides, or add a -5 if you want to look at it that way. You end up with these canceling, and you have y is less than. Now be careful here. This is that common mistake a lot of you are making. It's a negative plus a negative. So hopefully you all knew to add those, and you keep it negative. So y is less than -12. And now when you went to graph it, I'm going to go ahead and start -12 about here. Remember, this is going this way. And you have to be really careful with negatives because you have to stop and think about this here. It says y is less than -12. There's no or equal to, so you're just going to put an open dot at -12. Now you have to stop and think about this. Is -14 less than -12, or is -10 less than -12? If we were talking about positive integers, we would look at 10. Because it's negative, they're going this way to be less. The higher that negative number gets, then actually it's worth less. So all numbers that are less than -12 are on that side of your graph. All right, our last example is a real-life application. I'm not going to write anything on the left about it because you're just going to use the same rules we talked about, but it's showing how you would set up an inequality over setting up an equation. So you've done a lot of these problems already in Chapter 2, but you set them up as equations. Now you're going to be looking at it based on more than one possible answer with an inequality. So I'm going to go ahead and write it out. It says the maximum safe load of a chairlift is 680 pounds. A cyclist rides the chairlift, so this must be during the summer, a cyclist rides the chairlift with his bicycle. I'm just going to put with his bike. The bike weighs 124 pounds. I'm sorry, the bicyclist weighs. So the cyclist weighs 124 pounds. And the bicycle weighs 32 pounds. Write an inequality that describes how much additional weight the lift can carry safely. So hit pause, finish writing that, and then I'll start it when you unpause it. Once you looked at this, what you want to do is you want to go through, and when you're doing your homework, I don't mind if you don't want to write the whole problem out, but you should definitely be just writing out key things. So something like maximum safe load is 680 pounds. The fact that a cyclist weighs 124 pounds, that the bike weighs 32 pounds. And then also you want to look at the final question. It says write an inequality, so I know I'm not going to be using equals, that describes how much additional weight the lift can safely carry. So those are my key things. And now you want to start just like you were with the word problems. You want to look and you want to say, okay, well, what is it talking about? What is it? I don't want to say equal to because this is an inequality, but what is, if I was using equals, what would go on the side by itself? And hopefully most of you noticed it's the maximum safe load. So the maximum safe load is 680 pounds. So I know something is going to be a relationship to 680 pounds. Then I also know that I'm adding up stuff to get to weights. So I've got the cyclist weight plus the bike's weight, but then I also have this variable. So I know something is going to relate to 680. And if I think about that, I know it's going to be the cyclist plus the bike plus additional weight is going to be some relationship to 680. Now you have to think about that. Is all of this going to be greater than 680 or is it going to be less than 680? So you always ask yourself that question. Obviously, we don't want to go over 680 pounds because that isn't safe anymore. So all of that stuff needs to add up and be less than 680. And then the final question you should ask yourself is, can it equal 680? And because it said the maximum safe load is 680, then that means that it can go up to 680 pounds. So that is or equal to. On those, you always can use or equal to. If it said has to be less than 680, then it's not or equal to. So now you need to figure out which one your variable is. You can call it A for additional weight. And you just go fill everything in. So I have cyclist, which is 124 pounds, plus the bicycle, which is 32, plus any additional weight has to be less than or equal to 680 pounds. And now you're just going to go through and solve it. Draw your line. On the left side, you have like terms you can combine. You end up with 156 plus A is less than or equal to 680. And then from there, you're going to solve for A still, so you would subtract 156 from both sides. And you get A is less than or equal to 524. And then if you're going to write this correctly, then you need to go ahead and say the chairlift can carry up to 524 more pounds, which means it could carry 100 more pounds, it could carry 200 more pounds, it could carry 250 more pounds, but it can't carry 525 pounds. All right, I'm going to have you try one more of these. So it says your class brought 42 blankets on Monday. Your class brought 42 blankets on Monday. And 65 blankets on Wednesday. Write an inequality to describe how many blankets. So I'm just going to put write inequality. To describe how many blankets the class must donate on Friday to make or to exceed their goal of at least 160 blankets. All right, so hit pause, finish writing that. And then once you're done writing that, try to set this up on your own based on what we just did, and then hit play and watch how I set it up. All right, so hopefully you at least tried it. If you didn't try something, just try something so that when I go through it, then you can actually look at where you're making your mistakes. But what I would have done if I was solving this is first I would have gone through and highlighted important information. 42 blankets, 65 blankets. The word inequality tells me it's not equals. It's something greater than or equal to, less than or equal to, or greater than or less than. And then how many blankets? This is your variable. You always look for that. The class must donate on Friday to make or exceed at least 160 blankets. Oh, and I forgot least in there, I just realized. Sorry. Go like that. Sorry about that. At least 160 blankets. So you're looking at something needs to be set up to 160 blankets. It's that same idea again. You know that you started with 42, then you added 65, and then your variable is whatever you're going to bring Friday. So I used B for blankets. So I might even put up here B equals blankets. Now you have to decide, does this all need to be greater than, or does it need to be less than 160? And once you set that up, hopefully you noticed it said at least, which then a lot of you are going to want to use a less than sign, but this is what we talked about in our last lesson. It's that it has to be larger than it because that's the least it can be. So it's actually a greater than sign. And they said to make or to exceed. Make or exceed. So that's the make. They can meet 160 or they can exceed 160. And all I asked you to do in this case was set it up. I think by now most of you have an idea of how you would solve it, but we're not going to worry about that. It's harder to set it up. So I will see you tomorrow in class and we will work more on these.